Okay, so I will start sharing my screen. Okay, I hope that you are seeing my screen. Can you confirm, Giuseppe?
Yes.
Okay, perfect. So as Giuseppe has presented me, but I'm Miguel Caballer from UPV, and I'm going to present the infrastructure manager, and in particular, I will present the infrastructure manager dashboard, that is the web interface in order to easily deploy the virtual infrastructures on top of a wide range of cloud providers, and in particular on top of EGI Fed Cloud. Okay, let me introduce the service. The infrastructure manager is a service that enables to deploy any kind of virtual infrastructure on top of cloud resources. It uses two different languages, the native one that is called RADL, or TOSCA, that is an OASIS standard, in order to describe the virtual infrastructures. So the IAM uses the infrastructure as a code paradigm, in a way that a single document can describe a whole virtual infrastructure. And then the IAM gets this document and automates all the steps needed in order to get this infrastructure fully working. It automates the deployment of the virtual machines, the configuration and software installation, the monitoring, and the update of the virtual infrastructure. As I said, it supports a wide range of cloud backends, making the user applications cloud agnostic. Some of the features of the infrastructure manager, it has DevOps capabilities. It is based on Ansible in order to describe the recipes in order to install the software in the virtual infrastructures. It also provides a set of recipes for a set of common deployments, and it also supports Cloud Init scripts. But mainly in most of the recipes, we are using Ansible in order to configure that, as it is a high-level language. And the IAMS works as a service, and it offers different interfaces. It has two different APIs. One is an XML-RPC and a REST API. It has also a command line application to interact with the service, and two different web-based GUIs. We will see in the next slides. And all the software is distributed with the GPL license. It's all open source, and it's available on GitHub. We can see the link in the slide. So the general view of the platform, the IAMS allows to deploy customizable virtual infrastructures with the precise software configuration required by the user. So it allows to deploy any kind of complex infrastructure. In particular, it also enables to deploy hybrid deployments in a way that you can have a set of virtual machines working in some site, and if there are no more resources available, you can deploy another set of virtual machines in another site, maybe another previous site, or maybe you can use a public as Google, Amazon, Azure, etc. As it uses an infrastructure as a code paradigm, it enables to share infrastructure descriptions among different researchers. And it doesn't need to use prepackaged virtual machines images. So it enables to use any kind of, let's say, vanilla images using a plain Ubuntu or CentOS image. And using the different recipes, it will work on top of any virtual machine image. So the same complex infrastructure that has been described can be deployed both on premise or in a public cloud. This is the current support list of cloud providers. From the public ones, we are supporting AWS from Amazon, Google Cloud, Microsoft Azure, T-Systems OTC, Exascale, Linode, and Orange. On-premise platforms, we are supporting OpenNebula, OpenStack, CloudStar, VMware, and federated platforms as EGI Cloud that was initially supported using the OCCI interface, and currently we are using the OpenStack one. And we also support container platforms as Docker or Kubernetes. An important thing is that the infrastructure manager has been developed in a plugin way, let's say, that enables to easily extend the list of providers without too much the deployment. And this is the working scheme. So the users has to describe the infrastructure using their RADL or TOSCA. As I said, the RADL is the native language. It comes from Resource and Application Description Language. It's a high-level language that we developed with the IAM, but it enables to specify the VM requirements. And then we also add support for the TOSCA OASIS standard, in particular the YAML spec. And then in the next slide, I will show a bit how this two language works. But in this moment, I will stop a bit with the presentation. I will show how the IAM dashboard works. I will show a bit how it works. Then I will launch an infrastructure, as it will take some minutes in order to have the infrastructure deployed. We will back to the presentation. I will show a set of slides, and we will go back to see the infrastructure has been deployed successfully. So this is the landing page of the infrastructure manager dashboard. It uses EGI check-in in order to enable authentication of users. So I will access using my EGI check-in account. As I have previously logged in, I don't have to log in again. And we access the main entrance of the web page. That is the list of currently available topologies that the user can deploy. We have different set of topologies that we are using in the current implementation. And if you are interested in add a new topology or modifying the current ones, if you want to use it, you only have to contact us, and we can work together in order to expand the number of topologies. You can see we have some typical examples of an Slarm cluster, an Apache Storm cluster, a combination of a Galaxy portal with a Slarm cluster backend, a Hadoop cluster. And in this moment, we are going to show the Kubernetes cluster, as it is currently one of the most used examples. When you go to the configure section, you get a list of inputs that we will see in the next slides that are mapped some TOSCA input parameters. For example, in this Kubernetes cluster, we can set a number of working nodes to deploy and the hardware features of these working nodes. We are asking the 2 CPUs and 4 GB of RAM, the same from the working nodes, and we also are asking for a persistent volume in order to be attached to the front-end node, in order to create the persistent volume of Kubernetes in that external volume. From respect the Kubernetes, we have to add some parameters. We can select the Kubernetes version to install. We have some flags in order to install for example, the Kube Apps application. That is an application that enables to graphically install Kubernetes Helm applications on top of the Kubernetes cluster. We have also support in order to add NVIDIA support to Kubernetes. And also we have the option to install a thread manager that enables to create secure certificates to your Kubernetes cluster. I'm not going to enter into much detail because this is very particular for Kubernetes. I will put some token in order to access then the endpoint. And we go to the cloud provider selection. Now I will select one of the providers that I have added previously, but in the next slides I will show how to add these providers. We have different providers as AWS, Google, this one that is our private cloud. But in the moment I will use some of the sites that are provided by the EGI Cloud, that is the NCG site from Portugal. And then we have selected the site. We see the site resource usage in order to see we have enough resources in order to deploy our application. Then we have to select the image in order to deploy the virtual machines, and we're going to use an Ubuntu 20 plain image. And then, well, I have to put a name to describe the cluster, and then we go to submit. Okay, here we have the previous deployed infrastructure that we have in my account, and this is the current cluster that we have deployed. You can see with a single set of clicks, we have deployed, or we are start deploying our Kubernetes cluster into a cloud provider. As I said, as it will take a bit of time, this deployment, I could hear this part of the demo. I will go back to the presentation, but you can see that the virtual machines start appearing here. And then when the virtual machines are fully running, the configuration step will start. So let's back to the presentation. Okay. In the presentation, in the previous slides, we have seen that IAM supports 2 different languages. I will give a brief details of both languages in order to make you know what are the possibilities that you have. In the case of RDL, it has this general structure. There are several keywords of Ansible, network, system, configure. That all of them have some identifier, and then all of them have a list of features. And all of features are a list of constraints that are separated by an AND clause. And the constraints are formed by a feature name, operator, and a value. We will show, it's easy to see using an example. So let's do one example first. In this case, you can see that we are defining a node type that is called node. We are setting that we want 1 CPU and more than a half gigabyte of RAM, and that we are attached to a network that is named net that we have previously defined, and we have said that we need that this network has public connection. And in the configuration section, we are using the Ansible language in order to define a task that is to create a user with a predefined password. And finally, we said that we are going to deploy 1 node of this type. But the IAM also supports TOSCA. But what is TOSCA? TOSCA comes from Topology and Orchestration Specification for Cloud Applications. It's an OASIS standard. In particular, we are supporting the TOSCA simple profile in YAML because the original version of TOSCA was in XML and it was not so user-friendly. and it was quite the process in order to define the infrastructures. And using this language that is a standard, we are enabling the portability of the infrastructure, the definitions among different cloud orchestrators. And this is an example of how a TOSCA looks like. In a TOSCA, we have a section that's called imports, because the TOSCA, we have a set of that are called normative types that are native to the TOSCA language, let's say. But we can also import our own defined types based on these normative types. We can see in the next parts. Then we define the topology template. In this topology template, we have a section that we are called inputs, where we define a set of parameters that the user has to provide. And this input section that are mapped into the form that you have seen when we have deployed the Kubernetes cluster. These input parameters that you have requested graphically in the web interface are obtained from the TOSCA document in this input section. Then we define the node templates. For example, in this case, we are deploying a Caballer application that is deployed on top of the host Caballer server that is defined here. That is a compute node that we require that has a public connection. We also require the VNC port to be accessible. And we require one CPU for this compute node. And from the memory, you're getting the value from the input parameter. And from the operating system, we are requiring a Linux Ubuntu system with version 18. And also the TOSCA documents has an output section. These output sections are the list of important, let's say, parameters that we want to get from the deployed components in order to access our application. For example, in this case, we are putting the IP of the server that we have deployed, and also the credentials from this from this server in order to access via SSH. But any other combination can be done. From the client side tools part, the IAM has a command line client. It enables to access the full API, the full access to all the functionality of the IAM. It can access both APIs, actually the XML or the REST API. It is deployed on Python, and it can be installed using the pip tool. Regarding the web tools, there are two publicly available web interfaces. The first one is the one we are showing mainly in this demo. That is the IAM dashboard. That is designed for non-advanced users. And the IAM portal is it has more functionality. It's almost all the functionality that the IAM provides. But it is not so easy to use for non-advanced user. This is why we have split these two different web portals. Also, both of them are available in the code in GitHub. So in the case of the web portal, it's the full feature web interface. It's designed for advanced user that has the ability to deploy your own topologies. The user that know about TOSCA, about RADL, and want to design their own topologies and create and share with other users their topologies. But the IAM dashboard is more designed for non-advanced user that does not know or does not want to know nothing about RADL or TOSCA, and they only want to deploy a set of virtual infrastructures. So in this case, we have seen, you only have to select it from a list of configurable list of templates. And we've seen that this part, configurable part, are the input section of a TOSCA document. Also, the IAM, as I said, is a service, and it provides two APIs, an XML-RPC and a REST API. In particular, the REST API follows the OpenAPI specification, and in the documentation, you can access the document of the OpenAPI specification with all the definition of the API. Now, yeah, I want to show also where the IAEMS is currently used. The IAM is used by the BMOS dashboard of EGI. It is used as the orchestration layer underneath the BMOS dashboard in order to create the VM topologies into the EGI Cloud sites. You have here the link in order to know more about this tool. It is also used by the Indigopass Orchestrator. It is used underneath in order to contact the cloud providers in order to deploy the virtual infrastructures, and also in the EC3, in the Elastic Cloud Computing Cluster, that, as Giuseppe has said at the beginning, is a tool that we also have developed at the UPB, that enables to deploy virtual Elastic clusters on top of any kind of cloud providers. And in this case, also the Indigopass Orchestrator 63 are also part of appears in the European Open Science Cloud portal. Okay, so now I have finished my presentation. So let's go back to the dashboard and let's see how it's progressing our deployment. You can see the infrastructure is already running. We have our two virtual machines, the front end and the working node. We can see here the log that it shows all the steps, the Ansible steps that are being made in both virtual machines in order to configure the Kubernetes. You can see what are the current steps. As you can see, it's a bit long. Okay, since that we are waiting the front-end node to be configured. And we can also see the particular information of each virtual machine. For example, we can enter here. We can see the information of the first virtual machine, that is in particular is the front end. We can see the IPs that have been assigned to the virtual machines, the information of the particular instance and where it has been deployed, the set of ports that are open and accessible from outside from these virtual machines, the hardware features. These are the SSH credentials in order to access our virtual machine. See the user and the private key that you can download or copy to the clipboard. And also the disks. Always the disk number 0 is the disk that it is the operating system disk. That is the bootable device. And this is the second disk that we have added in the TOSCA document. We have specified a disk of 10 gigabytes and where it is mounted and formatted. So let's copy the keyboard, then the private key, and we can create key.
Miguel, sorry, we are not seeing your terminal.
Oh, sorry.
No problem.
Let me check here.
Yes, now we can see your terminal.
Okay, so let me go back to the dashboard. You cannot see now, but I am copying the IP because and now we can access our virtual machine. Okay, so in this case, I suppose that at the moment, I have to do this one. Yes, as you can see, at this moment, it is not ready yet, as we saw in the beginning. Let me change again to the dashboard. Okay, once as it is still configuring, we can see the different options that are provided in this part. We can see we can add more nodes. We will test it later. We can add new nodes in order to expand the number of nodes that we have in our cluster. For example, we only at the moment only have deployed one working node, and we see that we need more resources in our cluster Kubernetes. We only have to click here, and we can add new nodes to our cluster. We will do it later. We also can show the template. That is the original. This is, you can see it's a bit long. That is the original TOSCA document that we have deployed. Also, we can get the outputs. We have seen when we define a TOSCA document, we got an output section. This in particular, we have defined the Kubernetes dashboard endpoint, the API of Kubernetes endpoint, and also the kubeapps application endpoint. As I have commented previously, it's an user interface in order to deploy Helm applications easily. And also we can stop. Well, we can see that this finally configured. We can stop the virtual machines. It will not delete the virtual machines, only will, let's say, pause all the virtual machines of the infrastructure. We can delete or reconfigure. As you can see, once the infrastructure is fully configured, the default action is changed into the output in order to access our cluster. So it's supposed that now here, if I click here, I will have access to the Kubernetes dashboard. Wait a bit. Okay. Sometimes it gets sometimes from. Let's wait a bit because sometimes the dashboard takes sometimes in order to. But if we access to inside the virtual machine, we also have some options in order to manage them that are similar from the option that we have in infrastructure, but we have more options in this case. For example, we can reboot the virtual machines. We can terminate it. For example, in the same case that we can add a new virtual machine in our cluster in order to grow and expand our resources because we have a more workload in our cluster. Conversely, we can terminate in order to delete this virtual machine and release the resources that maybe not be used. And also we have the option to resize. For example, if we have created this virtual machine with 2 CPUs and 4 gigabits of RAM, we have an option to change and to increase or decrease the number of CPUs and memory. Okay, I see that Samuel want to ask something. I don't know if he can directly. Samuel?
Sorry, Miguel. Only in the end of the presentation, I was putting in the in
Okay,
the
don't
rule
worry.
to be. Sorry about it. Okay, I will wait for the end of the presentation.
Okay, so okay. Let's say now the dashboard is working. So now we can access our Kubernetes cluster using the token we have set as input in the input section of our cluster. And you can see it's the same of any other Kubernetes cluster. We can see here that we have the front end and the Kubernetes node. As I said, we can also try to have different options. For example, we can see here that we have this only two CPUs, and if we want to increase, we only have to put, for example, 4 CPUs and 8 gigabytes on write, are going to resize. In this way, you have to know that it implies a reboot of the virtual machines. So if you want to do this, you have to know that there is an application running, it would be rebooted. So you must done this carefully. But you have the option here in order to change the size of your virtual machines. It will take a bit because you have to contact the site and confirm that the virtual machine has been successfully resized. And then in some moment, we will see that during a period of time, this machine will disappear because it will be rebooted. It will be offline, but it will then increase the number of CPU cores and the amount of memory. Okay, the resize has been successful. We can see here that now the virtual machine has 4 CPUs and 8 gigabytes of RAM. Okay, well, this node is failed because it has been rebooted, and it will take a bit of time in order to get it back. Okay, the other option that have for elasticity, as I said, is to add a new node. We can click here, and we can set that we want to deploy one working node more. In this case, we can click submit, and a new virtual machine will be created, and it will start the configuration period. So it will take a bit of time because you have to create the virtual machine, start running, and configure Kubernetes inside the virtual machine. So in this case, this process will take a bit of time. It's about 5 of 10 minutes. We can see that we have now this new virtual machine, and let me say we have now the resized class, the resized node. It seems that it is not yet. Okay, it's not important. You just see in the previous slide that the machine has been resized, and you have this option in order to increase the size of the virtual machine if for a while you need more resources, or reversely, if you don't need so big virtual machines, you can reduce the amount of resources. And finally, I have to comment you about the credentials. This is one that I have not explained at the beginning. When we have deployed let's go back, for example, well, we can use in this case another one. When we go to the cloud provider section, we have a list of cloud providers. These cloud providers are defined here in this section. Here we have the ability to add different cloud providers that we have access. For example, I have quite a long list. We can define different credentials for different cloud providers, and in particular, we can define for the EGI Cloud sites. For the rest of sites, we need to know the credential that I provided by our cloud administrator or our cloud provider. For example, in the case of Amazon, we need the access key as secret key. In the case of Google Cloud, we need username, project name, and a certificate. But in the case of EGI Cloud, as we are accessing this portal as EGI check-in user, we have direct access. So we only have to select one BO that we are part. In this case, this is the BOs that I belong. So I can select, for example, the access BO, and it automatically will show the provider that I support in this BO. This information is obtained from AppDB. Okay, so this is the list of sites that are providing access to the user of the access BO. So we can select it, we can put a name, for example, Lil access, in order to know what is the combination of sites. And then we have here the this site. So in the next deployment, this site will appear here. Let's see that we can access the Lil site, and it will work as it works for the other site. Well, in this case, it's failing because we have not permissions in order to get the resource usage information, but we can still deploy. But in this case, the only difference that we don't know the information about resource usage. This is a particularity that some sites does not has enabled this feature. Okay, so we can see that this is still running. That is also configuring the third virtual machine and the second working node. But it is not a problem. We can I think that we can finish here. I only want to say that this you can have more information in different links. You have this EOS Marketplace entry here. There are some videos in YouTube. We have a YouTube channel in order to have some demos about how the IAM works. There is the different images from the IAM, also from the service of the dashboard or the different components. The source code is in GitHub, and this is the main information page of the infrastructure manager. And that's all for my part. So if you have any question, Samuel, you can